Okay, we'll go ahead here and get started. So welcome to the April 2020 KLUG meeting. This is our first one remote. Please bear with us if we have any technical difficulties. This is my first time doing this as well, so it'll be a little bit interesting on all accounts. So this is about 3D printing. I've been 3D printing for a couple of years, trying to go through some of the basics. As far as initial announcements, Tina said there aren't any. So as far as that goes, there's no official KLUG business. I will say if anyone wants to join the Rochester Software Devs Slack group, please let me know. I can send out an invite link for that. That's where most of the KLUG, etc. people are hanging out. It's a good group of guys. Outside of that, I don't think there was anything else. Just some bookkeeping to get started. I will be trying to watch the comments. If you have any questions, throw them in there. I am also on Slack on the Software Devs Meetup group. I have that open. Feel free to throw something in there if you really want as well. I think that covers all of our initial stuff. So the figure out for 3D printing, the first thing we have to figure out is all of the different kinds of manufacturing there are out there. So for years and years, the only kind of manufacturing we had was subtractive. So subtractive is where you remove material from something else, and that would be something like carving. If you're carving, you're taking material away. This is your classic definition of going through and, subtractive manufacturing. You can throw together a computer on there and, carve things faster, but this is still removing material. The other example is a lathe or a CNC mill. So either of these, you're removing material. When we're talking about 3D printing, we're talking about additive manufacturing. This is where you keep adding things that weren't there initially. So you keep adding material. So the first example of additive manufacturing I have is Lego. So you start with nothing, you put the little pieces together, build up whatever you want to show. So if you want to build a castle, you get your bricks, you get your idea, you go step by step, putting all of your bricks together to make your little castle. When we're talking about 3D printing, we're usually talking about some sort of machine that will do it for you. This is more or less uh, a an analogy of when these technologies came out. So binder jet was the initial technology that's been around the longest. And this is a very expensive process. This will usually be a few, $100,000 for one of these machines. This is basically a powder in a giant bin. So you have this bin of powder, and then there's an inkjet that runs over it. And the parts that you want to keep, you hit with the inkjet that will solidify the powder. And you keep adding another layer of powder on top of that, inkjet all of the stuff together, and eventually at the end of it, you have a solid object in the bunch of powder. You can remove all the extra powder that didn't stick, and you end up with something like this. For many years, this was the primary source of 3D printing. This is used a lot in industry. You can go ahead and see plenty of examples for this. But this isn't really something that you can put in your basement and just start churning out stuff. These machines are really expensive. They're the size of a large washing machine for the smaller ones. You have all this extra powder around. None of that's really fun. The next one that happened is basically the exact same thing as before. So you have SLM, which is selective laser melting, or a selective laser sintering, depending on your process. And this is almost identical to what the previous process was. You have a giant bed of metal powder. Wherever you hit it with the laser, that melts, and then you do that layer by layer, just adding more powder on top, lasering the next layer. And by the time you're all done, you have a solid metal object in a bed of metal powder. Again, this is what's used in industry. So this is the process they use to make turbofan blades for jet engines. Mercedes-Benz uses this for brake calipers on F1 race cars. I believe Bugatti uses it for some of their components as well. So this is a very expensive process. You know, these machines are hundreds of thousands of dollars, but you can do these really intricate geometries that would basically be impossible to do with a traditional subtractive process. You couldn't get a drill bit in there to cut out all of these, tiny little features. So it's used in industry for that sort of a thing. This process has been around for many years, very expensive. You won't really ever see this at home. The next process, I don't really know where this falls in order, but this is stereolithography or SLA printing. Um, Up until maybe, I want to say 3 or 4 years ago, this really wasn't a hobbyist type of device. But a lot of the technologies that have come out have drastically brought down the price. So now for, I believe Prusa sells theirs for about $1,000. This Formlabs example is about $1,000. And there are even cheaper ones that are just a few $100s. And this is a kind of a reverse process where you have a giant bath of resin. And under the bath of resin is a display. The reason these came down in price is they started using just your standard cell phone display. So this is a cell phone display that everyone has in their pocket. They're a few dollars each. Um, and what happens is uh, the display will shine through the resin, and when it hits the plate or the rest of the resin, it will solidify it. So it's basically like a photographic process. Wherever you shine light on, the resin will harden. So basically what happens here is that large portion on the top sits in the bed of resin. They shine light on it in whatever pattern you want for that layer. Then the bed moves up slightly and you do it all over again. Um, the big feature of this is you can get very, very high resolution. So you can, if you're doing, inch tall miniatures for your D&D campaign, this technology really works well for that. The other advantage is it has basically all prints take the same amount of time. Since you expose the entire layer at once, your only time variable is how tall the object is. So if you want to do 15 D&D miniatures that are an inch tall, that takes the same time as a single one. Uh, it's not a technology I play with yet, probably something I'll get in the future. The one downside for SLA is the resin is toxic slash carcinogenic, so you definitely want to wear gloves, have uh, a good PPE when you're working with this stuff. And usually the resins need to be cured and washed afterwards to get any of the liquid resin off. So that washing is usually just dipping it in isopropyl alcohol, and then it's usually UV cured, so you can leave it outside if you don't live in some place like Minnesota. Um, cool technology, prices have come down. Great if you're working on very small items, and especially items that you don't need to be really strong. This usually isn't the strongest, or items that have very weird features that would be difficult with other technologies. And then the technology that most people think of when they think of 3D printing, or if you've seen any 3D printers before, is FDM, which is fused filament fabrication. And this is more or less a hot glue gun. You put plastic in one end, it heats it up, it squirts it out, and if you do it in a smart pattern, you can get all sorts of different interesting items coming out of it. So this is more or less what you're thinking about if you're talking about 3D printers. This is the original Prusa Mark 1. I don't even think they called it a Mark 1 back in that time period. Um, and this has seen an explosion. There's probably uh, well over 100 different manufacturers of FDM 3D printers. Prusa is one of the really big ones, and there's just dozens and dozens of others as well. Um, this this entire stack kind of occurred because of the open source community. So there's an open source community called RepRap that started building these. So they put together some plans, and then they designed a controller board for it, and most of it uses basically the Arduino set of microcontrollers. So there was this ecosystem of open source plans, things you could basically get from hardware stores, uh, put together in your basement, build one of these machines. And this started roughly a decade ago, and after this occurred, there's been an explosion in the technology. So people have figured out what works, constantly tweaking on these designs, working on the firmwares. Most of the, at least more inexpensive type of printers use one firmware. It's called Marlin. It's open source. Anyone can work on it. So there's a constant influx of new features, higher reliability. And the way this works is you have a bunch of stepper motors. That's the large black squares on either corner. And that basically allows you to move all of the axes in very small increments. So if you're smart and can tell it move the stepper motors in certain directions, you can get it to print things. The one feature you want to look at is the hot end. This is, again, the hot glue gun of the 3D printer. So the metal bit on the bottom that's brass colored is the nozzle. And as you'd expect, it's a nozzle. It's got a hole in it. They're made of brass. They have different diameters. You can get very large nozzles. Large nozzles are great if you want to stick out a lot of filament, make something that's very strong. It's great for very high print speeds if you want to print large items. And then there's smaller nozzles as well if you want to have much smaller features. If you're trying to get down into the, inch tall miniature range, a smaller nozzle will certainly help with that. Above the little brass bit is what's called the heat block. It contains the heater element, and this is just a DC, usually 24 volt, some of them are 12, heater. So it's resistive. You put power in, you get heat out. Next to it will be a thermistor, which basically tells the uh, printer how hot the filament is, how hot the heat block is. Above it, that big ribbed section, that is the heat break. So you don't want your filament melting too early. So the heat break separates the hot end from the rest of your filament. So this allows the filament to slide in. Usually there's a fan on the heat break to remove any of that excess heat. So you want a very short zone between melting and not melting. And on the top of that, there's usually some sort of a guide to guide the filament in. So what are we talking about for filament? This is what the filament looks like. I just realized that Google messed up my slides, so you can't see all of those extra words. Uh, what the filament for an FDM printer is basically a long string of plastic. Generally, it's 1.75 millimeters in diameter. The more consistent the diameter is, generally you'll have slightly better print quality. It comes in all shapes and colors. Here's a couple of color examples here. You can do everything from every color of the rainbow. Sometimes they'll put wood in it, which would be like a wood-filled filament. There's carbon fiber embedded in filaments. There's clear filaments, and then there's a bunch of different filament types. The most common or the initially used filament was ABS. So just about every plastic item in your life has ABS in it in some place or another. That's the black pipe that you use for sewage is made out of ABS. It's relatively nice to print with. It's very easy to get raw ABS. It's used in industry. And it makes relatively nice prints. For many years, ABS was the primary type of filament that everyone used. After that, PLA, which is the other name you can see here, is polylactic acid, and that is uh, a basically bioplastic. Uh, it is much softer than ABS and melts at a lower temperature, and you end up with basically better quality prints. So if you're printing something, it will usually be higher quality out of PLA, but it is nowhere near as you know resistant to the elements or heat as ABS. That's the main filament. Primarily, what I will print with is PLA, just because it's so easy and it's definitely the cheapest of the options. The other option is PETG, which kind of straddles PLA and ABS as far as easy to print. PETG is easier than ABS, I find. It has much better physical characteristics. If you're trying to build some sort of a physical part, PETG is usually better for that. It's higher heat resistant. So if I'm building anything structural, anything that will hold things together, I'll do that with PETG. There are, of course, other filaments. There's TPU and TPE. Those are usually flexible, which are usually much harder to print. But sometimes if you wanted to print a phone case or a cover for something, the TPU, TPE is used for that. A lot harder to print than the others, but you get flexible materials, which can let you do some really interesting things. The other thing I should mention is not all filaments are created equal, especially with ABS. ABS is definitely smells way more than the other filaments, and there are a few people who warn about the fumes themselves. It's best not to sniff, melting ABS for extended periods of time. If you want to use ABS, you generally need some sort of an enclosure just to enclose all of those fumes, just for safety's sake. So here's an example of FDM. So I've told you a little bit about the background. This is what it looks like. I found this on the good old interwebs. So you have the nozzle. In this case, it's taking a picture of the hot end and the nozzle in the same spot. But it's basically going layer by layer, squirting out a layer of plastic, and then you get this end result. So that's a short summary of how these printers work. You, of course, have various restrictions on what you can do. Um, Hollow things are a little bit harder. You can't obviously bridge. A bridge would be going over clear air. Bridges are a lot harder to create because the filament is, basically semi-molten plastic and it will droop down. So it's very hard to get a high quality from that. And also you can't print it off into thin air. So if the nozzle was extruding, you would just get a giant mess of spaghetti. So you've seen how the printer works. The question is, how do you actually print anything? The generally 99% of what you see on the internet for things that are designed to be 3D printed will be in what's called an STL file. And this is a very basic configuration of, it's basically a triangle mesh. So it says, here are all of the triangles, here is their position in XYZ space, and that defines what the shape of an object is. So if you go online, there's all sorts of places that you can find STLs at if you don't want to make your own. So one of the places that I always recommend, prusaprinters.org, has a bunch of STL files. These are created by the community. They are put up there for you to go out. Basically, you can download them, you can change them. It's basically up for the taking what you want to do with it. They have fewer number of prints at the moment. They're only at about 16,000. But generally I find that these are usually higher quality, and they have a pretty good web dev team, so the performance isn't horrible. Moving on to places that had horrible performance up till at least a week ago is definitely the most popular place to get objects you would consider printing. This is by MakerBot. They're a company that builds 3D printers, and they created this community to let their users and everyone else in the world share prints. Probably 90% of the things you see printed came right off of this. And this website is called Thingiverse, I believe. Um, I always try and drop the second I. But basically, anything you could think of, you can go around and find a print for it, download it, print it off. Your mileage may vary though. So now that we have an STL file, well, the last option is, of course, make your own. So if you are very uh, smart about working with CAD on or any kind of modeling software, so Blender 3D works well for this. Um, this is an example from Fusion 360. Fusion 360 is my modeling software of choice. It's free for basically nonprofit use. I think they say if you make less than it's like $10,000 a year, you get to use Fusion 360 for free. And I generally find this is one of the best options to work with, at least for me. Um, there's also Rhino 3D. Pretty much anything that can make 3D objects will work to generate STL files that then you can print. This is actually a really interesting example. This is one of the first things I ever modeled and one of the first things I ever 3D printed. I don't know if you can tell through the stream, but uh, this guy is called Eddie, and he is my father-in-law's tattoo. He has this tattooed on his shoulder, and he's had this tattoo forever. Uh, I decided it would be a great idea if I could brass etch a few copies of Earl for him, so he could have a keychain. He just refinished a car. I wanted a brass plate that had Earl along with some lettering on it. But I wasn't really sure with the etching process what it would look like when it was done. So what I did was 3D modeled this. This came from a photo of his tattoo. I cleaned that up in Photoshop, imported that into Fusion, and then I extruded the basically 2D image, created the shape around it. So this is just an oval with a little bit of raised text, and I printed both the positive and negative versions of this. Hit it with spray paint, sanded it down so I could figure out when I went to brass what I wanted to do with it. So this was the first prototyping I ever did with 3D printing, and this was my Christmas gift to my father-in-law. It would have been Christmas 2018. He was just overjoyed with the brass copy of his tattoo. So now that you have your STL file, so you've downloaded it online, you've created it yourself, you need to go through a process that's called slicing. There's a couple of slicers out there, and depending on what your printer is, that will determine what slicer you can use. Generally, every manufacturer has a slicer they recommend. The original open source slicer is called Kira. Kira is open source. You can work on it if you want. Pretty much all manufacturers have some sort of a profile that will work with their printer. All of the printers have different sizes, restrictions, etc. So the actual print instructions aren't compatible across the printers. So you have to take your solid model, your STL, figure out what you're going to do with it, and that's what the slicing process does. So what the slicer does, it figures out all the models, subdivides it layer by layer by layer, and then figures out the instructions on how to make each layer, and then prints that out into an instruction file that then you can put in your printer. And the instruction file is relatively simple. So this is G code, and this was originally created for industrial development. So for running CNC lathes, CNC mills, it's an instruction format that basically says, you know, use this part, move this part to this location at this speed. This is an example G code I created last night of one of the prints I have going right now. And generally, this is 90% of the instructions you'll see. So what it's saying is move the x-axis to this location, move the y-axis to this location, and do it at this speed. So that's the x, the y, and the e. And it's basically just thousands and thousands and thousands of these instructions saying move the hot end at this speed to this location. Um, there's, of course, more commands for changing how fast the filament comes out, changing the temperatures, moving the nozzle up because you have to do that at least once a layer. And all of that's figured out by the slicer. You generate this. Not something you generally have to look at. I generally don't, but it's a fun way to dive in and see what your prints are actually doing. I wanted to give a quick call out to safety. PLA is really safe. As I said before, I don't think it's real. You wouldn't want to inject yourself with it, but there's not really any fumes. It doesn't smell bad. ABS fumes can be very, very bad. You want to stay away from those. Hot ends are very hot. They're usually about 230 degrees centigrade. That's more than hot enough to boil water, and it's more than hot enough to burn yourself. Probably the most common way to hurt yourself with a 3D printer is touching the hot end and getting burnt from that. And the other just this should be obvious to everyone, but don't go and stab yourself. It's not something that you want to do. A lot of times you're trying to clean something up or, pry things off of the build plate. Those sorts of things, make sure you're either wearing gloves or, practicing in a safe direction. I've had one injury like that. So what can you do with it? Everyone came to see all of the cool prints that I've done. So I have a couple of examples. And my first story is my last piece of advice where I said that you shouldn't stab yourself. So I was working, I printed something that needed some support material. So that's some material to hold it up in 3D space. So you'll build a scaffolding underneath it. And that'll allow you to, print over open air. After the print is done, you can scrape away the support material. I have a couple of picks that I use for that, like dental picks, and that usually works really well for me. So one night I printed something, it had some support material, I'm scraping away at it with my pick, and I drive that pick right into my thumb. I'm like, that wasn't smart. And I, put everything down, run to the kitchen, run water over it, put a Band-Aid on it, and I was bleeding everywhere. So I turn around and you could see spots of blood from my 3D printer over the carpet into the kitchen where I finally, got the towel and cleaned it up. So licking my wounds, literally and figuratively, I 3D printed a traffic cone so I could put it over the little blood spot in the carpeting. I don't have this print anymore, but I thought this was a really fun story of how I messed up. This is a really dumb one. You can never get the last bit of soap out of the soap bottle. So I got a new bottle of soap. The old bottle of soap still probably has an ounce in it. And I wanted to empty out the old soap into the new soap so I could use it all. And you can never like jury rig it. You can like try and like use a piece of tape and try and lead it against something. And that really wasn't working out. I'm like, wait, I have a 3D printer. So I grabbed my calipers, measured the external diameter of the threads on this, and printed a tube that fit between these two bottles. Probably took maybe half hour from conception to having the finished part. And now I can drain out my soap bottles. So uh, one of the things you can do that I find is really useful is just these little utility items. I've printed templates for uh, drilling different items. I don't know if everyone else has the same problem, but for like power strips, you have the like two little X holes on the bottom of them, and you have to line up a pair of screws exactly the right diameter apart. They have to be in, the right angle, and then you put your power strip on it and try and get it over those screw holes. And I am really horrible at that. So what I've started doing recently is just take a very accurate measurement of how far it is apart, print a template that has the holes in the right spot, and then I have a drill guide for whatever I'm doing. I know this is probably a failure on my part. I'm not very good at tracing apparently, but this has been really effective for, mounting network switches, that sort of a thing. Another one is miniatures. I'm not big into the like D&D scene, but this was actually for my sister. She had a D&D campaign that she was running, and she needed a dragonborn sorcerer. So she told me what this was. I went out and found a print, and as you can see, this is only a couple of inches tall. Um, and this took me many, many tries to actually get this done. One of the things you can see is it's missing part of it would be our left foot. This is one of the failures. There were many other successes after this, but this really stretches the limits on your 3D printing skills on, can you get something this small, this delicate, with this many things sticking out to print really well. So I ended up getting this all done, sent it off to my sister. I believe her D&D campaign was later stopped, but she has her miniature if she ever gets back into D&D. Next one is one of my favorites. This is my army of gnomes. Another fun story. So this is a battle back and forth that my in-laws and their neighbor have had. So the past 5 or 6 years, they've been hiding a gnome in each other's houses. So it's, your standard size garden gnome. Um, the neighbor really doesn't like gnomes, so the in-laws thought it would be a fun idea to go hide a gnome in their house. So for the last couple of years, they've been moving the gnome back and forth between their houses, hiding it, under the sink and, in the toilet tank, things like that. And we had this horrible idea of, well, there's no rule that says we can't have more than one gnome. So for Christmas last year, I 3D printed something like 30 of these miniature gnomes. So there's two kinds here. There's one that has a chainsaw, and I have a single example of him at the moment. Those are just teeny tiny chainsaw gnome, and there's a slightly bigger version as well. And I printed up a pile of these. We mailed some to the neighbor's nephew to hide in various places away from his house. And then my father-in-law spent a couple of days hiding gnomes all over his house. To this day, he is still finding gnomes. Some of them may have been rehidden. So for better or for worse, this is one of the more fun things you can do is, 3D print practical jokes. And to make it even better, this last Christmas, I 3D printed a massive gnome. So this sits about 1.5 feet high. This gnome was printed in 3 different sections. We then super glued the 3 sections together, epoxy coated it to cover up any of the layer lines. Then my wife went and painted rather, this entire gnome guy. We packed them all up in a giant box and gave it to him for Christmas this year. So most of my 3D printing time in December was spent, for the past 2 years, was spent on practical jokes slash Christmas presents. One of the last examples I have is there's all sorts of various miniatures that you can print. Most people have put things together of, name a TV show, name a TV character. They're going to have some sort of a print for it. Around Halloween last year, I decided that I needed a skull. If I was going to go for a skull, I would print a Pokemon skull because it looked really cool. So this is a couple inch 3D printed Cubone skull on top of a Pokeball Plus. And this came out really well. As far as printing Pokemon, my in-laws showed up last year, uh, or my who would be my cousins and my aunt and uncle showed up last year and stayed with us for a couple of days. So I 3D printed all of their favorite Pokemon before they showed up, handed them the 3D printed Pokemon, and they just about lost it. They had no idea what to say. They thought that was the coolest thing ever. Ever since then, if I know one of my friends is into Pokemon or has some, sort of defining characteristic, I'll 3D print something like this to hand them. So I have those were all of the prints that I don't have copies of anymore. I have a couple other prints that I wanted to show off as well, just to show all of the, kind of random stuff that I have before I actually go and show you my printers. Let's see if I can get this the way I want it. So I showed you the small version of the Cubone skull. I also printed a very large version of the Cubone skull. He also has a LED light inside of him. So he sits on the top of my steps like a gargoyle, and he was out there for Halloween. So I had a ominous glowing Cubone skull. And this turned out really well. It took a very long time to print. One of the things is I had to do them in two parts. So you can see there's a little bit of a line here. It's very hard to print like this teethy bit. There's not a lot of surface area to hold it if you're trying to print like this. So by splitting it along this line, I was able to print the top half perfectly well and the bottom half perfectly well, and then glue them together later. This turned out relatively well. There's a little bit of surface issue. I don't know if you can see that very well on the top, but it turned out great. This is one of the things you'll see if you ever visit my house. What else do we have here? Um, 3D printed chip clips. We didn't have chip clips. I had lots of chips, especially now that I'm stuck inside so much. So I 3D printed this. So this is built in, it's flexible, it holds on pretty well. That was fun. There's also a dinosaur version of the chip clip as well. So he will bite down on any bag of chips that you have. What else? This is a vase. I'll show you a version of this printing. This prints in what you call vase mode. So this is only a single line wide, and this makes it really fast to print because the nozzle never has to stop. It just does one continuous fractal pattern, basically, in this case. But it just slowly increases in size as it goes up. And this is one of the demo prints that you'll see. If someone's showing off their 3D printer, they'll usually print something like this because it looks really cool and you can almost see the filament going down. Connectors for things. This is another big class of things that I've printed. Connecting Dyson wand part A to this would be a standard, I think it's an 1.25 inch vacuum. So a small shop vac is this size. So I didn't have any accessories for my small shop vac, but I had plenty of these sitting around from the various vacuums I've destroyed over the years. So this is just a part I grabbed off of Thingiverse. There's just the solid body, And then there's also a 3D printed button that just kind of slides in. And you can see on the inside where that clicks in. So it ends up, I didn't have to do any modifications to it. It clicks in rather positively. It won't come out, and it works great. Connecting random part A to random part B is always a good thing you can do. Along the same kind of like utility items, I printed these as just a pair of 3D printed convex and concave parts. I had a little piece of steel that I needed to bend to fit on my smoker outside, meat smoker, and I didn't have any good way to bend any metal, especially it had to be very close to this angle. So I figured out what the diameter of it was, drew a chord across it, and then made the part A and part B. So these parts go together. I put my piece of metal on there, clamped it together, and that gave me a form to, press my metal together, and that worked great. It doesn't take too long to put together, too long to print. Uh, One of the other things that I've printed a lot relatively recently are these containers. So it's a mesh basket. There is a funnel that goes on the top. This is for storing desiccant. One of the things that you want to do is keep your 3D printer filament very dry. So 3D printing baskets to store desiccant is a great way to do that. And it has a little cap that goes on the top of it. So, I have everything I need to store my desiccant in with my filament. Let's see, we have a question. Okay. I have a question about software. What software do you use to edit or manipulate the files? Can you recommend good 3D printing software on Linux? So on Linux, the options are, I believe it's FreeCAD, which is like a programming language for CAD. So you can say, I want, it's basically its own DSL. You say, I want a circle. I want to make it this tall in this location. It's the very Linux administrator way of creating files on Linux. Uh, the There's a web browser based piece of CAD software that I'm blanking on at the moment right now. That should be able to edit things as well. Blender is one of the best. I've never taken the time to go learn Blender, so I can't really say, what all the pros and cons of it are. I know it has a very steep learning curve, but that's one of the options as well. And then as far as slicers, uh, Cura and Prusa Slicer both work on Linux as well. So that should be uh, pretty much everything available on Linux. Windows and Mac have all the Autodesk tools. Yes, OnShape from Killer Kitten. Um, that's one of the browser-based ones that's really good. I don't know if SketchUp is still supported on Linux. Um, they've gotten relatively weird. In the past, I used them on Linux, I believe, but that was a long time ago. SketchUp's really good for editing STL files. So let me know if you need any more recommendations than that. And then that covers most of my prints. I have one left that I wanted to show off. So with the current COVID-19, uh, a bunch of the community has went together and has started 3D printing face masks. So this is I believe this is the Mark II version of the Prusa face mask. So the little nubs along here. You use a hole punch to punch a 8.5 by 11 sheet of clear plastic, and then it kind of snaps onto the hooks. And then you have this piece, which will go on the bottom of the sheet to keep it curved. And then you can use a piece of elastic to go over the ears and uh, basically hold it onto your head. And Do I have anything else on my presentation, or is it demo time? I think so. I'll finish up the rest of my slides. I got one or two more things to talk about, and then I'll take you a demo of my 3D printers. So everyone wants to go buy a new 3D printer. There's thousands and thousands of 3D printers that are out there. Prusa has shipped, I think they're past 1 million of them sold already. So I can't really go out and recommend like one 3D printer. I'm really happy with the ones I have, which are both Prusa Mark 3S and a Prusa Mini. Um, they're a little pricier than some of the others, but the technology and the ecosystem is always changing. If you're new to 3D printing, uh, these are the features I would look for. One is a flexible build plate that lets you get the items off of the 3D printer without having to resort to a scraper. That really makes a big difference and can really help out. Uh, you're not going to break anything. The other one is a filament sensor. If you're printing something that takes 36 hours, you really don't want to be 35 hours in, run out of filament, and then your print is ruined. Filament sensor would let you, would basically pause the print when you ran out, reload, and keep going. Crash detection is relatively new, but this will figure out if it's running into something. It could be a human, it could be your part came off and it's running into the side of your part. That's also a great feature. You want to make sure that it won't catch fire. Some of the very cheap 3D printers are known for catching fire. I keep a smoke detector near my printers just in case something goes wrong. They put out, a couple hundred watts heat. That's enough to, catch plastic or, various other things on fire. Uh, Good slicer. Most of the slicers are roughly equivalent these days, but the slicer can affect how easy it is to print and then the final quality of your prints. If you want to use flexible filaments, so the TPUs, the TPEs, so anything that's somewhat soft, you need a direct drive that basically minimizes the, the distance from where the filament is getting pushed to where the hot end is. That's a big deal with the really soft filaments. And then you also need a healthy dose of being able to go fix things. Uh, 3D printers are great. They're always breaking. There's always something else to go wrong. And I think the one thing that fell off the end of this slide was automatic mesh. Oh, there it is. Automatic bed leveling is a big deal. The original 3D printers, you would have to manually level the bed, and that would normally you would have various screws, and you're trying to get the bed in relation to the hot end perfectly level. Because if it wasn't, you would have one side would be up off the bed, so it wouldn't stick, and then in the worst case, it would actually run into the bed. Um, Most of the mid-range to high-end 3D printers have a automatic bed leveling system, so it'll actually detect how far the hot end is from the bed and will adjust the print for that. And the high-end ones will do mesh bed leveling. So if your bed is tilted or is not uniform, it can automatically compensate for that as well. I was going to do a little bit of a PSA on COVID-19 and decided that since this is going to be on the internet for more than 24 hours, whatever I could say here will probably be wrong in 48 hours. Uh, what I can say is there are 3D printing communities who are doing whatever they can to help out. There's thousands and thousands of 3D printed masks being created. I know Stratasys, who builds 3D printers, donated some to Mayo. I believe Mayo assembled 500 of those the other day. Um, There's various other things for making your own bias tape, for sewing your own cloth masks. So there's a lot of prints around those sorts of things. The technology and the landscape is constantly changing. I won't really give any recommendations here, but there are plenty of people out there who can definitely give great examples of what the community has found useful for 3D printing. So I have a question from Dean. If you buy the kit version of a 3D printer, how hard is building it? Um, that's a very good point. So the standard-ish 3D printer, you're probably talking about like a Prusa Mark III. They're usually sold as a kit. Um, those are fairly involved, but they have great instructions. I did it with a friend together between the two of us with every automatic screwdriver that I had. I think we had it printing in under 2 hours. I don't think there's a world record for it yet. Usually they say the Prussias would take 4 to 8 hours. I would guess six-ish is probably an average for that. All of the tools come with it, just like IKEA. The instructions have, pretty pictures through the entire thing, so anyone can do it. It's just relatively time-consuming, and the instructions usually have some sort of release notes as well. As they find tips or as things change, they'll update that. And this is my last slide. So here's a list of extra resources. This is all of the YouTube channels that I follow. Thomas Sandler does a ton of cool 3D printing stuff. 3D Printing Nerd is out of, I believe it's Seattle. Um, Great produced 3D printing channel on YouTube. CNC Kitchen does a lot of more analysis. So, figuring out, how hard things are, will things break, what are the limits, how strong is different kinds of materials. I shared the Prusa 3D printing handbook. This is all of the resources for anyone who's getting into 3D printing, like, how to configure things, what things you have to look for, what do you have to know, basically a great getting started guide. And then Make every year does a 3D printing shootout, which is a review of all of the 3D printers. For the past couple of years, the various Prusa models have won their number one prize. So that's why my brother started with Prusha's, and I've kind of continued with that. They have really great service as well. So I'll throw all of these links in the YouTube description at some point in the future. Oh, so my wonderful wife. So the question is, you mentioned using epoxy to smooth out your prints. Can you give me more detail about how you apply the epoxy and what epoxy I use? This is from Smooth On. They're one of the biggest epoxy slash resin companies out there, and they came out with this XTC 3D, which is a standard two-part uh, resin that you mix together. It's a very thin resin. You apply it with a brush, uh, and the it takes, I think it's about 15-minute setup time, and then 24 to 48 hours to fully cure. And that ends up giving a very nice, very smooth finish. Um, and that can be really useful depending on what you're doing. It's not too expensive. It's like 15 bucks, and a little bit goes a long way. You only use a couple ounces at a time. So that's a really great one. I think that does it for all of my slides and all of the content I have prepared. So now I get to try and live stream from my GoPro to show you my printers as they're printing. This is my main go-to printer. So I'm currently printing that fractal vase that I showed off earlier. So you can see the head as it's moving. I don't know if you can actually see the nozzle if I get down close enough. But there is the 3 axes plus the filament. So you have the 2 axes. These will both move at the same time. These move the hot end up and down. There is another stepper in back with the belt. It moves the bed forward and backward. The stepper on the side will move us left and right. And then this stepper right here is what actually drives the filament down. So the filament is coming down through this pipe, goes in the top, and then there's a little geared tooth that will push it down. I happen to have a Raspberry Pi 4. That's this item right here. That is running a Raspberry Pi camera, so I can live stream my my prints as they're going. I can check them outside of the house if I wanted as well. I have a little 24 volt to 5 volt power supply that pushes the power up to the Raspberry Pi 4. And I have a couple little accessories for doing things like changing nozzles and cleaning things. This is a Prusa designed enclosure. So it has magnets to hold the doors closed. All these orange parts I printed myself, and this basically cuts down the noise, definitely. It's not very loud as it is, and also any of the fumes. The other advantage of this enclosure is it keeps the temperatures a lot more consistent. If you're printing ABS or PTG, sometimes it'll want to warp if it cools at different rates, and the enclosure helps out with that. And this is just a pair of IKEA tables that you get for $10. 3D printed hardware all around, and then I had the plexiglass cut at local glass place. And then I have my this is my dry box for my filament. This is what keeps my filament dry. So there's desiccant on the inside that keeps the filament dry. There's a pair of rods that the filament can roll on, and it basically just pulls the filament straight out of the box. My humidity sensor right on the front to let me know how dry it is. It's about time to change that filament. And then I have to clean my bed. I use isopropyl alcohol and a rag. If there's any oils or anything like that, it won't stick anywhere near as nicely. So that's a short summary of it. Trying to think if there's anything else cool to show off about this. Oh, here are all of my extra. So this is a 3D printed torque wrench. I believe it's about 2.5 Newton meters is what that says. So this will torque in your nozzles. They need to be torqued to that spec. And then this is the all of the nozzles that I have. So I have various sizes from 1 millimeter in diameter all the way down to, I believe it's 0.15. So that would be 0.20. The standard nozzle, as you can see here, is 0.40. That's the standard size that most 3D printers come with. And then I have all the intermediate sizes, and a couple of steel nozzles. Some filaments will wear out brass, especially like carbon filaments. So steel nozzles are really good for that, but they have slightly different thermal characteristics. So this is the original Prusa Mark III's. This was a kit. I did assemble it all myself. And then moving on to the Mini. This was my second printer. This is the Prusa Mini. This would be what I recommend to newer people who want to get into 3D printing. This kit, it basically isn't a kit. It comes in like 2 pieces. You can put this together in 30 minutes or so. And it only prints, the bed size is much smaller. They've definitely considered cost when they were building this. But it is a very solid 3D printer. It has the bed sensor, which is right here. So that tells it how far it is from the bed. So it has the automatic bed leveling. These bed plates are removable. So it's magnetic, and this magnets onto the actual part that's heated. So when this finishes printing, I can rip off the entire thing, bend it, and then my print will pop right off. This has a relatively nice interface. It has built-in Ethernet. The Ethernet doesn't work yet on these machines, but they promise it will in a future update. So you can control it remotely if you connect it to your network. I got a standard roll. This is Prusa Mint. This is Prusa's brand of 3D printing filament. Like it pretty nice. Makes nice prints. I'm trying to think if there's anything else about the Mini. It is a Bowden system, and Bowden is the drive for the filament comes from back here. So there's a gear in here that pushes the filament up through this tube and into the hot end. So it's basically pushing a long string through this hose. That's generally not a problem for some kinds of prints and filaments, but that means you can't push a rope. So if you have a 3D, if you have a flexible filament, or you have things that have lots of retractions where you're trying to like pull it out and push it in all the time, it doesn't work as well for that. And the Prusa is basically a direct drive where that stepper, instead of being back here. That's all I had prepared. If there aren't any other questions, I'm gonna bid everyone adieu and stop the stream here. This will be recorded. The same link that you saw here, you'll be able to see in a bit. And have a great night. Everybody stay safe, and don't do anything I wouldn't do.